the recording. So let me test speaker. Okay, let me. Hello. Hello. Okay. So once you are done with this one, and of course, these 3D drawings will not be available to you. This is the first and only time I am actually even making a 3D drawing. You will just see a side view. Okay, let me finish my drawings and then we can start. So the 301 exam was good, right? 301 was good. Okay, we can probably discuss later. I was just curious that because you are one of my students. So okay, so I will repeat the same again. This question is the values have been made by me, so that's why I'm a little careful. 1 kilonewton is not a big load, by the way, you can see. So since I am the one who is making this problem, I have to be careful. Then you can just repeat the same thing. So every single thing in this problem is the same. I will just put a hinge here, a roller here, and you can add the rest of the things yourself. And if you can please copy paste. Now it will be 150 by 25, okay? So I just want you to have a very clear understanding of 150, okay, by 25. So you will see a huge difference. And let's call this chunk as A. This is my B. Of course, you can put a roller here as well. Okay, I think we are ready. 2 minutes. Okay. Hello, Abdullah. How are you? Good, good. Okay. Uze, can you hear us?
Yes, Sushil.
Okay, great. So this is the problem. Just to be clear, your 206 exam is this week, right? 27? 27 means
Next week Wednesday.
oh really? So it will be during the class?
Yes.
Okay. So please remember that everything from the beginning of the semester till, so this topic is included. The beam bending is included. So everything. Are you getting my point? Hmm? Beam bending is included. I do realize that you will be concerned about the practice problems. So I can post few good problems and you will do okay. You will do, all of you will do okay. Okay, do this problem. So what is the number one observation in this problem? This is a pure bending problem, number one. Number two, when the load is acting, observe how the 1 kilonewton load is acting. Hello, good morning. 1 kilonewton, of course, could have acted here, could have acted here. That's not the point. The point is, look how I have put the 1 kilonewton load. Do you see this line right through the center? Are you getting my point? I placed it very intelligently right on this line. Why? Because had I placed it here, like here or there, what would have happened? Torsion would have happened, twisting would have happened. That would have become that would have become a little more complicated problem, something that you would go through in 434. Instead of instead of using the word twisting or torsion, my point is, okay, forget about the words. My point is, I'm not placing the load at that point. I'm not placing the load here. I'm putting it right here. So number one, this is what we discussed last time, if you remember. Number two, do you see that the load is acting straight down? Had I placed the load here like this, are you getting my point? Or had I put the load like this, what would have happened? The load would have acted at an angle. I'm not putting the load at an angle. The load is very straight. Again, we are allowed to use our discussions that we talked about last time. So all the checkpoints are done. Number two, is this object symmetric about the y-axis we talked about, right? Is this object symmetric about the y-axis? Again, it is. So all the checkpoints of my last discussion are tick, 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 tick. If all the checkpoints are done, this is the coordinate system that I always use, by the way. I am very comfortable in them. I put my y like this. I always put my x along the beam. I put my z like that. So the formula was, again, you missed some critical information. What I have talked about is that from the beginning of the semester, everything is included for our 206 midterm 1 exam. Even this topic of beam bending is also included. Okay, the second thing I said was that the load is acting straight and all of that. I think I have already clarified. Minus m, what was the formula? Look at your notes. Okay, I already know the formula. I just wanted you to look at it. Minus m, then there was y, then there was I. Then with this m, I will put a z. Why? Because I have put an x there. I will put a y here. Why? Because I put a x here and a z here. Then I will put a z here. Look at your notes, by the way.
Is this face support, is it the corner or the middle of the face?
What?
This support is
It is
at the corner or at the middle?
support. You mean this one?
Yes.
It is at a corner. But why did you say it is in the middle?
So I asked, is it in on middle or corner?
Oh, you mean here or in the middle? You mean like that? No, it's in this corner and there is another spot. Okay, hang on. You will not be seeing any three-dimensional drawings. This is the first and last time I'm making a three-dimensional drawing. So it is here, there is another there, but you can forget all of that. You can just imagine it in a two-dimensional plane, make a beam, put A here and B here, that's it. I'm making it three-dimensional to But that is a good observation. You can actually make it in the middle, by the way. Good. Very good. You can make that one in the middle and remove the two rollers and put one. That's fine. Okay. Then stress X equal to, I need the mz. What is mz, by the way? I will have RA plus RB equal to 0. Statics. Okay. Then in my statics, they told me this is 1 kilonewton. I think it is acting in the middle. I will skip those details. 500 Newton will be supported by A and 500 Newton will be supported by B. Got it? So I will say RA equal to 500 and RB will be 500. We don't have any student who is
in RA plus RB equals 0. Instead of saying 0, we need to set 1 kilometer.
Okay, I made a mistake. Thank you. You are right. Critical mistake. Thank you. Okay, then we have minus RA multiplied by X, right? Plus M equal to 0. I'm telling you, if someone is not sure about these steps of statics, you do not hesitate and raise your hand and tell me and I will repeat. But I'm skipping them thinking that you have studied in statics. Then I have M equal to RAX. And I know that the maximum moment will act at the center for me. You can make a bending moment diagram if you want. So M equal to 500 into X. The maximum will happen at 2.5. So give me the value. 1250? Any student who is not sure about these things? Now that I know the maximum moment, I will go back and I will finish the question. This is MZ, Z, Z, Z. Students who are getting confused, how do you know this is moment about Z? I will explain them by like this. The beam is bending like this. Okay, horrible drawing. Hang on with me, please. Boom. Boom. Look at like this, right? So the fingers of the right hand, right? So thumb is pointed towards me. That's how the beam is bending. So makes sense that the moment that is being created by this load, that's in the Z direction. So this is surely MZ. And now I will say stress X equal to, do the number crunching and give me the values. Everyone is sure, right? Hang on. Where is the neutral axis, by the way, in this problem? No, middle of what? The fiber that is right at the center, like this fiber is your neutral axis, okay? I think I need to explain this because we studied this last week. Some of you have forgotten. So this fiber is the neutral axis. Why? Because this is a rectangular structure. And I know that the neutral axis goes through the centroid. So you see these fibers, all these fibers right at the center, these constitute my neutral axis. Okay, so I think this is the first problem I need to help all of you. So minus MZ is 1250 Newton meter. Any student who can give me the Y, because I want maximum tensile and compressive stresses. Excellent answer by one of the students. He said 75 millimeter. Good observation. How did he figure? Because if the neutral fiber is this fiber, then the maximum you go away from that fiber will always give you maximum stress. Is it visible? The light blue color. Okay. Divided by IZ. You do it yourself. Trust me, you can get confused in this step. There is a reason I'm making you do this. Give me the IZ. BH cubed by 12 is a formula from our high schools. BH cubed by 12. This is from statics. So what I'm doing is I'm taking a knife and I'm cutting it right through here and throwing this chunk away. Then I have there are a lot of steps to it actually. I just skipped it so I can explain like this. So I actually made a free body diagram. I made a cut. Then this is my A. In that cut, I put one downward. This is M, which is taught to me in my statics classes. Then I said minus RA multiplied by, I called this as my X plus M. Okay, everyone, I have skipped these details, okay? But don't hesitate, please. Ask me. Abu, ask me, what happened? Sure, okay. Yes, we had a question. Somebody, yes.
for maximum tensile, in order to find the maximum tensile, we set for y 75 divided by
Huh.
1000.
Haha.
So when neutral axis,
Is the neural axis is at the center?
that's a
Look. If I'm bending it, by the way, someone gave me the ballpoint. Who gave me the pen last time? One of the students gave me the pen. You gave me the pen, okay. So you can pass back his pen. If you are putting a load like this, right? The top surface, for example, will have the maximum compressive stress. The bottom will have maximum tensile. So the furthest you go from the neutral axis, the highest stresses you will find there. Anyone who did the moment of inertia?
Yes, 7.2 times micrometer.
7.2 times micrometer. Okay, I don't have the value, so I will, for the class, I will do it. Probably this is how he did. Iz equal to b h cube over 12. Then what I'm sure the thought process is, look at here. Follow me, please. This is how it's bending, right? Everyone? Sure? If this is how it is bending, for me, it's the Iz. So he considered this as base.
I didn't use that formula.
What formula did you use?
I used b times h divided by 12 times b squared plus h squared.
Huh? You have to show me. B by 12, B square, B
H and b
So what is this quantity?
the height.
But it will change the formula.
Yeah.
Oh, no. You use this one. I will explain the reason. Okay, BH cube by 12. So the base is our, did I give you 25? 25 by 1000.
It's 1 micrometer, 1.05 micrometer.
Okay, 1.05. Good. Multiplied by H is given to you as 150. Over 12. 1.05. Okay, 1.05 micrometers. Okay. Iz. Do the number crunching and I will get 1.05. As I told you, I am the one who is taking these numbers, so I was a little careful. I hope that the answers are not unreasonable. So the stress X comes out to be okay, hang on everyone. Are you getting for finding Iz? Why did I consider this width as B and this as height? Because when it is bending, look at from here, it is bending like this. Look from here, it is bending like this. So when it is bending like this, it's the Z, right? Look that the curve is right next to the Z. So when it is bending, this is Z. That's why I'm more concerned about the Z. Give me the value.
You mean the IC or John?
I'm talking about Iz. Because when it is bending,
Points 0.3 times 10 to the power minus 6.
oh, you are getting Iz as 0.03.
7.0. Yeah, I mean,
Okay, that's fine. So you can, all of you can give me the new value. Okay, say that again. 7.063. Okay, give me the stress X, please.
$13 megapascal.
13.
Okay, it's not unreasonable, I guess. Okay, hang on. So is this the compressive stress or tensile? I suppose this is the compressive stress because the Y value I substituted as positive. So I'm talking about the top surface. What about this is compressive. What about the maximum tensile? So I will repeat the process. Stress X equal to, now I will go from the neutral axis. In which direction? Negative y, right? So minus 1250 Newton meter. Students who are getting confused, I substituted a positive value. Now I will substitute a negative value because I want to go to the bottom. Then I will do divided by 1.05 into 10 power minus 6 meter, and the answer will be positive 13 megapascals. Boom. Confused? Clear?
Confused for the sign.
Yeah, I will tell you. Look at this y. Look at the sign. Positive. If it's positive, look at this y. Positive. If it's positive, where is your line? This is your line, right? Positive y. Okay, so I am talking about this surface now, because this surface from this line is 75 by 1000. Okay, the answer comes out to be negative. Does it make sense? Oh yeah, for sure it does. Look, load is acting like this. The pen is bending like this. The top surface will have compressive stress. So I'm getting the negative answer. Now consider this line. Go towards the negative 75 by 1000. What surface do you encounter? Oh, come on. What happened to Zoom? Okay, I will come to this surface, right? The one at the bottom, correct? So when y is negative, I am getting an answer of positive. Hang on. What about this negative sign?
That's the formula.
That's the formula. Good. This sign you are not allowed to play with. You can play with every single thing, not the sign.
What if we have negative moment?
Good question. So let's do that. Okay, I will not do the whole question. I will just make a remark. I will answer. Yes.
Which is our answer.
Huh?
Which is our answer.
Okay, our answer is this is our maximum compressive stress, and this is our maximum tensile stress. Okay, his question is, what if the moment is negative? You see this purple 1 kilonewton? In an exam setting, very important comment, Abu as well. If I put the moment in the exam from the bottom and I remove this moment is now moment is acting like this. This is bending like this. So the moment will be negative, right?
Mindset direction.
Are you getting my point? Huh?
So it depends on direction of the force.
Huh?
It depends on direction.
So it becomes like this, right? Okay. Yeah, hang on. If it is acting like this, then good. Okay, now I imagine. If it is acting like this, then the moment is negative because you curl the fingers of your right hand, the thumb is pointing inward to the board, and the inward is actually opposite to this z direction. So your mz will be negative. And now your top surface will be in tension. Your bottom surface will become in compression. Did you get confused by this explanation, or did it get better? Okay.
And when that happens, we have positive y and then negative, and then positive. So that makes sense because we will have positive values.
Okay, I think I can do similar problem like this later. Right now, for the many students, I don't want to confuse them, but you are right. I think you got the point. Good. Should we do one more problem? Of course, not one more problem. Many problems. You do this problem yourself. Same problem. Same problem. Only thing is that the beam was like this. The beam was like this, right? Look at the rectangle. I just flipped it. Should I go back? Okay. Take a picture. Okay, we have some online students as well. Mehmet, is it clear or not? Do you want me to explain any portion? Jose?
Can you repeat the part where it's like plus and minus tau?
Yes. Why not? Look. What I was saying was that your neutral axis is right through the center. Okay. What I'm saying is my y is positive upward, my y is downward negative, right? For every fiber that is top of neutral axis, it will be y positive, right? I put a y equal to 75 by 1000 because I wanted to go maximum upward from the neutral axis fiber. So I put positive 75 by 1000 here. By putting a positive 75 by 1000, it automatically multiplied with the negative of the formula. And I got a very beautiful negative answer, and every student said negative means compressive stress. So I wrote it like this. Then I substituted y equal to negative. And the answer came out to be positive, and students said this is maximum tensile stress. Okay.
Okay, Vijay, thank you.
Okay. So I will say stress X equal to negative. What was the moment? 1250. Multiply by y is 12.5 by 1000 divided by moment of inertia. You are doing it on calculator. You have to give me the moment of inertia on calculator.
1.1 micrometers.
0.19 micrometer. Give me the moment of inertia. One of the students has given us moment of inertia. Mehmet can give us the moment of inertia, or Uze can give us the moment of inertia, our online students. Okay. So I get 0.19. I will just write the formula Iz equal to. So this is our y-axis, correct? This is our z-axis. This is our x-axis. This is my y-axis. This is my. Okay, I got confused. This is our, if I'm looking from here, z-axis. X towards us. Okay, this is our, as one of the students said, x. So Iz equal to b, b, h cube divided by 12. Everyone is getting the same answer? 0.19. Hang on, I think the units are wrong, by the way. Please, everyone, the units are wrong, right? It's not micrometer, it's micro. Oh, hang on. So I think there is some confusion. So this is in meter power 4. So is this, you have to give me in 10 power minus 6. Is it like this, everyone?
Yes.
Right? Okay. Good. So don't use the don't use, because it's meter power 4 units. Okay, so this is okay, 0.19 into 10 power minus 6. Okay, then we have meter power 4. Okay, what is the value? Stress X.
82 megapascal.
Okay, it is 82 megapascals.
Minus.
Okay.
95.
I have a very critical question for the class. Very critical question. Hang on. By the way, this compressive stress is on the top surface or on the bottom surface? Top. Good. Everyone is with me. Abdullah is with us. I forgot your name, I'm sorry, and everyone, okay. So we have compressive on top surface, and then stress X equal to positive 82 megapascals. Where?
On the bottom.
On the bottom surface. Tensile. Jose, can you hear us? Everything is fine. Mehmet, everything is fine?
Yeah, hocam. It's fine.
Okay, which one is better?
On the bottom.
Right? Which one is better? I said which one is better. So the first case is better, right? For putting as a beam, I would prefer this one. I won't prefer this one. And it's very physical, right? If you have a thin ruler, you're putting a load, the ruler easily bends, right? But if, in fact, if anyone has a ruler, they can even try. And if you flip that ruler, you try to put the same load, that fellow is not going to bend that easily. So it makes sense. This is more prone to failure for the same maximum yield stress. That fellow is just awesome because you are using, right? I think it's clear. Good. So far, so good. How much time we have? We have time. I just want to be clear on one thing. There are some nice and beautiful drawings that are available in your textbook as well. Now, you may want to have a look at them because, but I will also draw them. So where is the neutral axis fiber? Fortunately, this was a beautiful rectangle. So all of us said right through the center fiber is the neutral axis fiber. Okay. Okay, I'm talking about, let's say, part 2. Okay, part 2. So for part 2 that we just did, 82 megapascals. I will do a hang on with me, please. So this one is compressive, the top surface. So I will actually draw a very beautiful line here. You may want to double check with your book, by the way. Then this is a nice and beautiful drawing that I'm trying to make, just for everyone to have a visualization. Now, even in last class, one of the students actually corrected me that the directions you are making are a little different than what he was thinking. My point is, as long as you understand what I'm doing. And the bottom surface, everyone said, is compressive.
The bottom surface is tensile.
Sorry, tensile. So if this is the center,
It's gonna go to
Right?
yeah.
left or right? This left-right thing is something that therefore, that's why in my notes, I just said this, I mean tensile, this I mean compressive. Yeah, it should be opposite.
The tensile part should be opposite, isn't it? Because when we press down, the edge want to go even further.
Okay, so you see, the same thing has happened this semester. So like this.
Yes.
I think he's right. But same as last semester happened. Compressive tense. That's why I'm more focused on writing like this. Okay. Beautiful. So far, so good. Okay, let's now make the distances. What was the distance? 12.5 and 12.5.
Sorry, hocam. Sorry.
Yes.
Hocam, I think the tensile part will be opposite direction because we are thinking that the final position is like orthogonal the surfaces. But initially it like this. So when you bend, the upper part comes to normal part, and also the bottom part will be in tensile.
Yeah,
Because of it, it goes like the orthogonal.
I think the reason he said is like this, I think he's right because because if this is the line and the top surface is bending, so the fibers will go like this.
Okay.
And if this is my line and I'm bending like this, the stresses will be like this from the fiber. The fiber will be stretched, the fibers will be compressed. So I think this makes more sense, no?
No, it's true, Hocam, but I'm trying to say that orthogonal one is final. The initial one is with an angle. If we making compression apart, like if you want, like
Angle is the moment.
this one, the final one is like this, and the initial one is this. When we compress, it comes like this, right? So the part, this line goes toward that part. While this comes toward that part, this line needs to come to that part. Like it comes like this, and we bend so much, right? It comes like this, and it will comes like this. Like,
I don't think that this line that you have made has anything to do with this. I
so which one? Yeah, I'm
It's
trying
just-
to
it's just-
understand
it's just that-
which one.
It's just that for this line, it means that there were no stresses. And when I bent, then the surface above from the neutral fiber, it had compressive stresses. So these lines, oh, okay. I understand your question. Look, you have to understand stress X equal to minus my over I, right? This is a linear equation. This equation is like y equal to mx plus c that they used to teach you in your maths classes. So the variation is linear. The higher you go away from the neutral fiber, it is increasing linearly. The stresses are increasing linearly. That's why you see this line. Similarly, you have y equal to mx plus c kind of an equation. The more you go away from the neutral fiber, you have a linear increase in the stresses. So this line, bent line that I'm making is a mathematical line. It's because it shows the magnitude of stresses. Okay, everyone, just one last question, because what is the stress here? 0. What is the stress here? Maximum. So y equal to mx plus linear variation. Okay, everyone, life is good. So I think this is high time that you can do one more problem, then we can call it a day. So again, this problem I'm intentionally making. I will try to make the values as physical as possible. So now this is more like a cantilever beam formation. You will not be coming across such kind of problems too much, but I'm intentionally doing it. So the first problem I'm making is like this. But second problem I will change a little bit intentionally. Let me come up with the values. So this is a cantilever. So the first problem is somebody is putting a load like this. Let me save it because the internet will go. Okay. Correct? Okay. This is our first case. I will call it as case A. My case B is a little different. Okay, and I will again make the same problem. Please do this problem and then our class will be over. The second case is I will make the same cantilever one more time. How will I change the problem? Any suggestions? So I will change the problem. Okay. So let me change the problem like this. Okay.
On the edge?
On the edge, but in this direction. So I have this as a P. Now the P. Now you have to put all those things to the test. The load is acting right on the center line, right? Right on the center line. The load is acting right on the center. Okay. Even here, the load is acting right through the center of this rectangle like this. Okay, number one. Number two, is the load acting straight? Yes. It's not acting at an angle. Everyone. Yeah, and Abu as well. The load is acting straight. It is not acting at an angle. Number three, is this object symmetric about the y-axis? Oh, yes. Huh? Symmetric about the y. This is a rectangle. So I will make the drawing again for you. Like this. Symmetric about the y-axis. Again, for this one, symmetric about the y-axis. So I will now put my, where will be the neutral axis? Right through the centroid. No problem till now. Nice and beautiful. Y. Z will be towards the left. Okay, and X will be outward. Okay, same here. Neutral fiber will be right through the center. Y will be upward. X like this. Z towards here. Okay, students who are getting confused, how do you come up with this X? Because my X is in this direction. My Y is like this. My Z is like this. Same here. My Y is upward. My Z is in this direction. My X is along this. And you can see this, that when I am looking from here, this Z will be outward. Y will be upward. Z will be like this. You can see here, Z towards the left, Y up, X outward. Is it clear? I'm making the same thing over and over again. Okay, let me give you some physical values. So let's say P is 500 Newton.
Sir, what if any of the condition does not satisfy?
Then you will not be able to do this problem with your 206 stuff that I have taught you. Then we are talking about 434. Which you do not know. So why would anyone give you such kind of a difficult problem? Because if the load is acting at an angle like this, it will not only bend like, it will not only be able to have a moment in this direction, it will also have a moment in this direction. So that will be more complicated. Right now, it's too difficult for you to even imagine that. So let's stick to a simpler case. Okay. Okay. What is the length? Okay. 5 meters. Okay. In fact, 5 meters. Nahin, make it 2.5 meters. I'm saying I want to make this as physical problem as possible. Not a hypothetical problem. Okay. Dimensions of rectangle, you can copy paste from this one. 150 by 25. We will do problems from your textbook. Right now, I am doing problems like these because I want you to have an understanding of every possible case. 150. Okay. You are doing it right. You will be able to do it. When you are talking about maximum tensile and maximum compressive stresses, you have to find the maximum moment first using statics principles. So if you're talking about maximum compressive and maximum tensile stresses, you have to find the maximum moment by using the statics principles, in which your professors used to teach you how to make a bending moment diagram. And in that bending moment diagram, you used to have a maximum moment. You find that one and then you proceed. Yes. And then moment.
There's a moment.
Yes.
So we're taking like this and the same thing for the maximum shear force will be.
Not shear force. For now, moment. Okay. So shear force will be the same as this one.
The shear force will be same as the P, like 500.
But the moment.
The to,
In this particular case, it will be 500 into 2.5. The maximum moment. The maximum moment will be the support of this object will be subjected to the maximum moment. 500 into 2.5. The support will be subjected to the maximum moment, nahin? Yes.
500 times 2.5.
Yes. So I will do it for you. Let's call this as your A. Let's call this as your B. So it will be MA. Let's say it is anti-clockwise minus 500 multiplied by 2.5 equal to 0. So the support is subjected to 1250 Newton meter. Then I will use the statics principles. My support has MA. Okay, internet gone. No, it didn't. Okay. My support has MA and this is clockwise M and this is V in this direction. So I will write plus MA minus M equal to 0 and MA equal to M. So M comes out to be 1250 Newton meter. Huh.
Is the stress in A is 80 megapascal and stress in B is equal to 106.7 megapascal?
Possibly, but I made the problem in front of you, so we have to do it for me to see the answers.
For the direction of MA, it should be like.
Anti-clockwise. MA is anti-clockwise.
I think
so-
It's in clockwise
No,
direction.
MA. So support has anti-clockwise, but you are absolutely right. If you cut from any section, it will have a clockwise. Okay, so please hang in there with me. This is the. So we have stress X equal to, one of the students have already told us the answer, minus. I think we are doing this problem first. Okay, so minus 1250 Newton meter. What is Y?
0.0125.
Good, good. Yes. Okay, no. Okay, 12.5 over 1000 meter. Okay, I value is, I think from our previous example, 0.19 into 10 power minus 6, right? Meter power 4. So stress X comes out to be, I think you already have the answer. Huh? 80 megapascal. Okay, and for the second case, it will be
So we compress this, right?
which one? This one?
Yeah. Minus, we put minus.
This is this. Sorry. So I think we have made a mistake. I apologize. So this is clockwise moment, as one of the students had told us. So we did not pay attention. Minus is from the formula. This is, you can see here, the M I have made is clockwise. So minus 1250. So the answer comes out to be positive. Now imagine, hang on everyone, you have a ruler, right? So look, you put a load like this, the ruler will bend like this. What happens to the top surface? Expansion, right? Tensile stresses, right? There is no right hand rule for this one. Huh? You have a ruler in your box, hold it like this in a cantilever formation, put a load like this, the top surface is expanding. So the stress X needs to be tensile or positive when it comes to a surface above the neutral axis. So my answer is also coming out to be positive. Now stress X equal to 82, not 80. Okay, we can discuss that, everyone, 80 or 82. But I need to finish this. I really do. So the other one is minus then you put minus 1250, then you put a minus 12.5 over 1000 divided by, then you put the same, what was the value? 0.19 into 10 power minus 6 meter power 4. The answer is again 82 or 80 megapascal, but this time in negative. Now, what about the second problem? For the second problem, I do not have any space, so I will go to the next slide. I will write stress X equal to minus mzy over I. Now, this is not even Z, I suppose. Wow, the problem is complete. I don't think we have time, by the way. We have to go to the next class. But I will just finish it like this. Look, in which direction is your force acting? It is acting in this direction. So the beam will be bending like this, right? So if you imagine it like this, look. It is in this direction, right, like this. So this means you will have a clockwise around Y, right? So it is you see the arrow in this direction, right? So it is negative my. Is everyone with me?
Yes,
Sure, everyone positive? Huh?
negative.
Huh? Negative my, everyone. Okay, very good. Everyone is with me, I suppose. So this is my. Then what about this fellow? So if I am talking about this fellow bending like this, then I have to talk about Z. How did you figure? I'm not sure. Excellent answer, by the way. Someone immediately said Z. Then what about the moment of inertia? If this object is bending like this, this means that it will either, it will actually, if I bending like this, then this means this object will bend like this, right? Are you with me? Right. So this means I have to talk about moment of inertia of Y. I have intentionally made a very confusing problem because I want everyone to understand that this is how you will. What about this? Still be X. Oh, so I will do the number crunching. We will have 1250. So we will have, one of the students told us that it is in the negative Y direction. So minus 1250. We have 1 minute. Z, where is my neutral axis? Now you have to understand my neutral axis. This is my neutral axis. It is becoming as confusing as it can. Look, this line is my neutral axis line now. The fiber here will not have any. So I have to go maximum towards left or right. And my maximum towards left or right is 75. Wow. Wow. This is amazing. 75 by 1000. Did anyone do the IY, by the way? IY is so it will be B H cube by give me just 1 second. B H cube by 12. So it will be hang on with me, please. 25 into 150 power 3. Time is over actually. 150 by 3 over 12. Give me the value quickly and then I will take your question. What is the value?
7.03.
7.03 into 10 power minus 6. Na? Meter power 4. Give me the final value. I don't know the values. What is 13?
I guess it's same as the previous question.
Sure. 1 3. Yes. Question.
No, I have a question, Hocam. We previously did the IY
You already did that?
calculation here in previous question, because I remember.
Oh, sorry. Okay. is this, does this make sense? Okay, anyways. So now, for positive Z, now you can imagine it like this, that when you are putting it like this, so the surface that is towards me will have compressive stress on it. So, why this is, oh Jesus Christ, why this is positive? Did I make a mistake? I surely did, I think. That will be tensile and this surface will be compressive. If I'm putting load like this, so that side will be in the negative Z, I will have tensile, but in the positive Z, I will have compressive. So negative moment. So did I make a mistake? I think positive answer. Why is this? That's not good. I think we can look into next time. Did I make a mistake?
If you bend like this,
Hang on. So if I'm putting a load like this, that surface will be in compression, tension. This surface will be like this in compression. So for a value of positive Z, I need to give a negative answer.
Yeah, for positive Z direction.
So why am I getting a negative positive answer? Minus I think it's because of this. So moment is negative, no? Because when I am putting a load like this, then I'm surely getting a negative My. Okay, so I think I will correct myself. Sorry. Here I will remove the negative sign. And now I will say compressive.
You know why we take the negative?
I took out the negative from the formula because your textbook actually only talks about the moment about Z and all the derivation is for that one. The derivation is not for this complicated problem that I created. So that's why I removed the negative from here. From the formula, I picked out the negative because I know that it was not giving me the correct answer. Like it's not like just to make the answer right, I just changed the formula. I am telling you that you have to remove the negative sign because I remember that in the next topic, even in your textbook, when he combines everything, there is a positive sign before this one. So that's why I corrected myself. Is this clear? Huh? Neutral fiber also changes. If your load is like this, my neutral fiber was like this. But when you're putting the load like this, then the neutral fiber somewhere lies like this. Thank you, everyone. See you in the next class. Bye-bye.
So, when we're talking about sigma S, sigma X, using information from Y axis, using information Y, we will changing the formula to not minus my.
You mean, why did I change this?
Yeah.
Okay, I changed this because I know, actually I know from one of the topics, then when the author combines both the two things for a general condition, there is a positive sign that comes here. So that's why I corrected myself. But please remember that in the formula, very simple formula like this one,
it will be
stress X equal to minus mcy over Ic. There are no cons. You have a negative sign here in the formula. But since I changed the problem to a very complicated one, I knew that there cannot be a negative in this new formula that I am making. So I had to remove this. Because it's very common that if you are putting a load like this, then this surface will bend like this. This surface will be like this. So compression here. So for a positive Z value from the neutral fiber, which is
there must be negative.
For sure. That's why I immediately.
Sir, with the drawing, I didn't really understand, but is P acting in the positive Z direction?
Ha, P is in this
How
case.
did you find moment according to y? Like why is it negative? I got confused.
Aşağıya
Next
doğru
time we will talk about it. I have a dynamic
Yani
class with you.
bu
Okay, bye bye.
taraftan-
The P times X yani
Ha bu yöne döner anlamında.
hani şey parmağının yönleri